Chapter 16 is on factoring. There are various types of factoring. You need to just recognize each type and practice. It's a skill that's very easily learned, and it's the reverse of multiplication. Factoring means to express the sum of quantities as a product. Let's go over the types of factoring. The most important and the one you should always follow first, if it is there, is a common factor. Always do this first, common factor, something that's common. If we have exactly two terms, one of the factoring techniques is called difference of squares. If we have three terms, we have three types of factoring. One where the leading coefficient of the variable is 1. The leading coefficient is not 1, it's greater than 1. Or a very special case, it's a perfect square trinomial. The last method of factoring is the method of grouping, which is based upon common factoring thinking. Always be sure to completely factor the problem, and you can check your answer, always check your answer by reworking it or remultiplying to get the original problem. Okay, let's take this problem, which is a trinomial. Let's first see if there's a common factor between each of the three terms. It looks like I found 2x is common. So 2x times 2x squared is 4x cubed. Minus 2x times 3x is minus 6x squared. And plus 2x times 5 is 10x. So I've underlined the common factor. I extract it, put a parentheses, and within the parentheses, I put the non-underlined quantities, 2x squared, minus 3x, and plus 5. If we were to distribute this, multiply it out, we should get back the original problem. The next problem is a trinomial where the lead coefficient is 1. This is relatively easy once you get used to the idea. It's based upon FOIL. Right now, the lead coefficient is -1. Working with a negative sign is kind of awkward. So what I did is I extracted as a common factor a -1 from each of the three terms. If I do that, what's left inside the parentheses is y squared plus 3y minus 40. The question is, notice that the lead coefficient is 1, understood. The question is, does this factor? It may not factor further. Let's look at the factors of the last term, 40. 40 can be represented as 2 times 20, 4 times 10, or 5 times 8. Does any one of these products either add up or subtract to give you the middle value? 2 and 20 add to 22, and 2 from 20 is 18. That doesn't give me the 3. The only combination I see that gives me the 3 is the 5 and the 8. So I put in the parentheses as the last term, the 8 and the 5. And now I have to come up with the sign of the middle term. The bigger number needs to be positive if I want a positive middle term. Make this plus 8y minus 5y, which gives me the middle term of 3y. And lastly, does a plus 8 times a minus 5 give me minus 40? Yes, it does. So the completely factored form of this trinomial, by first extracting the common factor of -1 and factoring the trinomial, is this answer. Lastly, let's look at this trinomial, which has a lead coefficient that is not 1, but I do see a common factor between the three terms. If I extract 3b from each of these three terms, I'm left with 15b squared, I'm left with a 19b, and I'm left with a 6. So I saw a common numerical factor of 3 between these three numbers, and a common factor of b between b cubed, b squared, and b. Then the question becomes, can I refactor this trinomial whose lead coefficient is 15? It's greater than 1. The way I like to do things, it's a little bit more organized. I take 15 and factor it as 3 and 5, 5 and 3, 15 and 1, 1 and 15. I factor the last term likewise as 3 and 2, 2 and 3, 1 and 6, 6 and 1. Notice I put the factors in both forward and reverse format. Then I would like to work with the first quantity and the second quantity by multiplying inside values and outside values. For the first line, 5 times 3 is 15, and 3 times 2 is 6, and 6 and 15 are not going to give me a 19, whether I add or subtract. Let's take this first combination with the second combination over here. The inside product is 10. The outside product is 9. I think if I were to add those two results, 10 and 9, I could get 19. So I'm going to put 3 and 5 as the first terms, 3b and 5b, and the 2 and 3 as the last terms in the binomials. I then need to figure out my sign. Well, the inside product is 10b, and the outside product is 9b. How can I get a positive 19? By making these two symbols plus. Do I also get the sign of the last term, plus 2 times plus 3? And the answer is yes. So I've completely factored the original problem by pulling out a common factor and then factoring the trinomial that has a lead coefficient greater than 1.